Hi everybody. This video explains you about avalanche transit time devices and what do you mean by the ATT device and IMPATT diode. Okay, I will also explain one of the avalanche transit time devices which is IMPATT diode. So coming to the avalanche transit time device, what do you mean by avalanche effect? Avalanche effect is nothing but generally it exists in the reverse bias condition. Okay, when we study the diode characteristics, there we will see in the reverse bias, forward bias characteristics and reverse bias characteristics. In the forward bias characteristic, all these microwave diodes are operated normally, which is equal to the normal diodes. But when we go to the reverse bias condition operation, in that reverse bias condition, up to certain voltage, the current increases as long as the voltage increases. But when a certain voltage called breakdown voltage occurs, the current drastically increases even if you increase a single point of voltage. For small changes in the voltage, the current drastically increases, that is called the transistor. The diode enters into the avalanche region. Okay, because this is because of the multiplication of charge carriers. This is because of multiplication of charge carriers. Okay, this is what the ATT effect. So I will explain with the diagram, we can understand. See, if you take the forward characteristics, this is V and this is I. In the forward characteristics, the current increases, voltage increases and current increases. But in the reverse bias condition, up to certain point, the current increases as long as the voltage increases in the reverse direction. But at this breakdown condition, the current drastically increases without any application of voltage. Okay, this current increment is due to the avalanche effect. This is due to multiplication of charge carriers. So multiplication of charge carriers in that particular region existed between the two regions, either p type or n type, then the current increases drastically. Okay, now I will write few points here. Avalanche region occurs in reverse biased junction, reverse biased condition. Okay, maximum amount of current flows in avalanche region. Okay, so maximum amount of current flows in this avalanche region. This is due to multiplication of charge carriers. Multiplication of charge carriers. Okay, generally all these now we will go into the avalanche transit time devices. Okay, all the devices which are exhibiting this particular avalanche effect, now we are going to call them as ATT device or avalanche transit time device. Okay, they are having some properties like negative resistance characteristics are generally exhibited by this ATT device. So negative resistance characteristics can also be obtained by providing negative resistance characteristics can also be obtained by providing a phase relay between voltage and current. See here, what is the advantage of negative resistance characteristics from any device? I told you already when I was explaining the characteristics of negative resistance. Positive resistance characteristics device will consume the power, whereas negative resistance characteristics device will dissipate the power. When we are going for this microwave circuits, a source is needed for the operation of the microwave circuits. Okay, a source is nothing but which delivers the power. So such type of cases, for the creation of source, we generally go for the negative resistance characteristics device, because negative resistance characteristic device will act as a sourcing device. It releases the power. Okay, but such negative resistance can also be, now what is our aim? We need to make the device as a negative resistance characteristics to make it as a use of source. Okay, so negative resistance characteristics now they can also be obtained by providing the phase difference between voltage and current. That means for positive current there should be a negative, sorry, for positive voltage there should be a negative current. For positive current there should be a negative current. That means if you take the graph between voltage, see this is time and this is voltage and this is time and this is current. If you take a graph like this, for this positive there will be a negative current, or for the negative voltage there will be a positive current. Okay, so this should be the relation, this should be the relation between the voltage and the current. Then we can say that device is having negative resistance characteristics. Okay, so the devices which exhibit this property is known as avalanche transit time device. The devices which exhibit this property is called avalanche transit time device. Okay, now the example devices are, first one, IMPATT diode, second one, TRAPATT diode, and third one, Barrett diode. Okay, so IMPATT diode. Let us see the first one, IMPATT diode. IMPATT diode. Okay, in this video I will explain completely about this operation and construction of this IMPATT diode. Remaining two I will explain in the next videos. See, the full forms of these diodes is, IMPATT is nothing but impact ionization avalanche transit time device. Okay, so impact ionization avalanche transit time device, first one. Second one is trapped plasma avalanche triggered transit time device. Trapped plasma avalanche triggered transit device. Third, Barrett stands for barrier injected transit time device. Barrier injected transit time device. Okay, I will explain these two in the coming videos. Now, what do you mean by IMPATT? IMPATT, IMPACT, impact ionization avalanche transit time. Avalanche transit time. This is what the full form of this IMPATT. So it provides a negative resistance using a phase shift between the current and the applied voltage. So provides a phase shift of greater than 90 degrees between current and applied voltage. Current and the applied voltage. So typically such type of avalanche transit time devices, remember all the avalanche transit time devices are made up of Compound materials. Compound materials you know very well, which is nothing but a mixing of two different semiconducting layers, gallium arsenide, silicon carbide, or indium phosphide. So like that, we are mixing two different semiconducting layers and creating a compounding material. So typically made up of silicon carbides, silicon carbides due to their high breakdown capacity, due to their high breakdown capacity. And as these are made up of compound materials, they are having high power handling capability. Remember this point, high power handling capability, high power handling capability. So IMPATT can operate, this diode, it can operate with a frequency range from, in frequency range from few gigahertz to few hundred gigahertz, few gigahertz to hundreds of gigahertz, hundreds of gigahertz. So it generates high level of phase noise and avalanche process. Okay, so it gives high phase noise, high phase noise in avalanche process, during avalanche process. Because what do you mean by avalanche process? As I said, avalanche process is nothing but a multiplication of charge carriers. So because of that, it will give high noise. So function as a microwave oscillator and used to produce carrier signal for microwave transmission. Okay, that means it will be used as, it will be used as oscillator, microwave oscillator. Okay, that means it is a sourcing device. Coming to the construction of this IMPATT diode, IMPATT diode is having a different regions, a combination of different regions, nothing but a P plus region, high concentration of P type impurities, that's why P plus region, and N plus region on either sides of this device. So P plus region, N plus region creates anode and cathode of this device. This may be the anode and this will be the cathode. Okay, so on either ends we are having cathode and anode as a property of the diode, which are made up of P plus and N plus regions. In between we are having one N region, lightly doped N type impurities N region, along with the drift region. This intrinsic region is for the drift region. This particular region will be used in the avalanche region. Okay, because of the negative voltage we are applying on this side, here it is a negative supply, here it is a positive supply to this N type, that makes the diode to be operated in the reverse bias condition. In this reverse bias condition, what happens? The barrier potential increases, this electric field will be developed more here at this particular region and creates a charge multiplication of charge carriers and creates some avalanche region at this junction, so that the electrons will be drifted in this direction and holes will be drifted in this direction. Okay, that's why this I is shown as a drift region. Now I have already explained in the starting of this video, in the forward bias characteristics there is no difference between the characteristics of the normal diode and this IMPATT diode. They are same, but everything is in the reverse bias condition. In the reverse bias condition, up to certain voltage we can say it is a breakdown voltage, VBD. Okay, so this up to this breakdown voltage, as the voltage increases in the reverse direction, current slowly increases, current slowly increases. We can say it is a leakage current. We can say it is a leakage current which occurs in the reverse biased condition. Until this breakdown voltage, it is slowly increasing. At this particular breakdown voltage and beyond that, current increases drastically, and due to the multiplication of charge carriers, maximum amount of current flows. This region is known as avalanche region, and the current flows is known as avalanche current. This is due to multiplication of charge carriers. Okay. Now our IMPATT diode is going to be operated at this particular breakdown voltage because we need to create some avalanche effect. Okay. See here, IMPATT diode operation. Then you may have a doubt, what is the difference between the normal PN junction diodes and this one? Normal PN junction diodes at this avalanche breakdown, they will be burnt off and you cannot use them later. But as this IMPATT diode and avalanche transit time devices are made up of compound semiconducting materials, they are having the capability to handle high powers. That's why even after the breakdown voltage occurs and remove the breakdown voltage, it again works with the normal operation. Hope you understand. Okay, but the normal PN junction diode will not work after the breakdown region, after breakdown occurs. Okay, see here, as I said, this is the cathode and this is anode, P plus N plus. As I said, the holes will be drifted in this direction and electrons will be drifted in this direction. So this is how the doping concentration is there. As pluses are there, plus is having high concentration. So P plus and N plus are having more concentration than N region, or Ni, or you can say it is I. Okay, different types of materials are going to be fabricated in between P plus and N plus. Different structures will be there. You can also call P plus I N plus as IMPATT diode. IMPATT diode can also be designed in this way. Okay, now if you see the electric field is more at this particular junction where the avalanche region occurs, and in the drift region it is having normal electric field, and beyond that it goes down. Coming to the operation of this IMPATT diode, now what I have taken is, I have taken this IMPATT diode and applied a negative voltage on the P type and positive voltage on the N type. Along with this biasing supply, we have also given some alternating current signal at this particular point. Okay, what happens now? This positive, this alternating signal, or some sinusoidal signal is superimposed with this biasing supply. Okay, so this biasing supply, as this diode is operating at the breakdown voltage, we are taking this voltage as the breakdown voltage, VBD. Okay, so suppose if VBD is something like minus 1.7 volt, or minus, we can, as it is more power handling capability, we can call it as something like minus 20 volts or minus 30 volts. This AC voltage is superimposed on this one. Previously the ground of this AC signal is 0, but now the ground becomes VBD. The ground becomes VBD. Well, what is that? Breakdown voltage. Okay, now the alternating signal, AC signal, is having a positive or negative cycles over a breakdown voltage. Okay, I told you at this particular, because of this negative supply to the P plus and positive supply to this N plus, the diode enters into reverse bias condition. So during this positive peak of this AC signal, what happens? The breakdown region is more because already it is given with the breakdown voltage. Okay, but now because of the application of AC signal, during the positive cycle, that voltage and this voltage is more, and diode is having more impact on the avalanche process. So charge multiplication of charge carriers is more in this particular region. That's why due to this positive peak, charge carrier concentration increases heavily because of the positive peak. Now because of this charge carriers, current also increases. Okay, it will not happen immediately, it takes some delay. Okay, that's why current also increases like this. Again, for one more positive peak, the same process will result. Again, for one more positive peak, the same process will be the result. Okay, now if you observe this waveform, for the negative peak you are having positive current. Again for the negative input voltage you are having positive current. Again here, here. Okay, so this is what the phase shift or phase difference between voltage and current. Phase difference between voltage and current. As voltage is positive, current is negative, that means the diode is operated with negative resistance characteristics, hence it is acting as a sourcing device. Okay, this is what the operation and construction and working of this IMPATT diode. Okay, so IMPATT diode is having some specifications, nothing but efficiency of this IMPATT diode. Efficiency of this IMPATT diode eta, we can say it is equal to 30%. 30% efficiency is there for silicon carbide. Okay, it depends on the material, it gives different types of efficiencies. 15% efficiency is there for if you take a pure silicon. 23% efficiency is there for gallium arsenide. See this. If you take the compound materials like silicon carbide and gallium arsenide, then the efficiency is more. But if you take a single material silicon, then the efficiency is very less, which is just 15%. Okay, and output power, maximum output power for single diode, maximum output power for single diode 5 watts in X band, 5 watts in X band to 0.5 watts at 30 gigahertz, at 30 gigahertz. So several diodes combined and gives 40 watts. Several diodes, if we are combining different several diodes of this IMPATT diode, it gives a 40 watts up to at X band, up to 40 watts, and frequency is 3 to 100 gigahertz. I told you few gigahertz to few hundreds of edges, so 3 gigahertz to 100 gigahertz. This is what the specifications of this IMPATT diode. Thank you.